on a graph is essentially I highlight the points that my graph cannot touch. So in this case, x cannot be 0, so that means my x-axis is what we call an asymptote. And I'm only going to write this word once because I never remember how to spell it. Asymptotes is a part of your grid or your graph that your function cannot touch. And because this is a vertical line, this is a vertical asymptote, and from now on, I'm not going to write this word because I'm a mathematician and I like symbols better. This is going to be called our VA. Our vertical asymptote is x equals 0. Cannot happen. Okay? Now, is it possible for y to be 0? Can I put a value in the x such that the whole thing is 0? Yes or no? I'm seeing some people shaking their heads and some people avoiding eye contact. Because x cannot be 0, and the only thing that will make something 0 is multiplying or dividing by 0, which you can't do, we can't have a y that equals 0 either. So if y can't be 0, that means I have another asymptote, the x-axis. Well, that was a really fat highlighter. That's okay. I have a horizontal asymptote. I'm going to call it an HA because now you know what the A stands for. Horizontal asymptote where y is 0. I cannot touch that line. So when I go to plot my points, okay, I'm going to erase this fat highlighter and I'm just going to make a dotted line instead. That's green. There we go. I'm going to plot the information I have. Can't touch 0, but 1 is 1, -1 is -1. 2 is 1/2. 10 is even smaller. And 1/2 is 2. So it's going to look a little bit like a water slide from Cultus Lake. And here, same thing. It's going to look like an upside down one. So I have a split graph, and it's split by the asymptote. Okay, so we have a table of values. We have what the function should look like. We know our asymptote. So what is the domain here? Do we have a restriction? X cannot be 0. But x can be anything else. So I have my restriction. I would accept if you just wrote the restriction that y cannot be 0. But technically, the full correct answer is you also have to tell me what it can be, as well as what it can't be. So it cannot be 0, but it can be all other real numbers. Do I have an intercept? No. No, because we cannot cross those lines. My asymptotes, spelled wrong because I think that's not supposed to be there. That's all right. So I have a vertical asymptote, x cannot be 0, and I have a horizontal asymptote, y cannot be 0. Yes, sir.
Could you go back to the graph?
Absolutely. Oh, my screen almost froze. There we go. Any questions or comments or concerns, things you want me to talk about more? Or are we ready to go to the next section? Got 2 left. All right, let us scroll. So this is a square root function. Square roots are the inverse of a square. So y equals x squared gives us a smiley face parabola. The square root is the opposite. So what is the opposite of a parabola? It's an x root. So let's take some points and see what should this graph look like. Let's do -2. Oh, no, it's the square and square root. Let's do nice numbers. -4, -1, 0, 1, 4. Let's do 9. Okay, so y is the square root of the number that we put into x. So what are my y values? No. Oh, yes, good catch. NA, right? We cannot take a square root of a negative number. Okay, so what's the next ones? 0, 1, 2, 3. Beautiful. So let's graph those points. 0, 0, 1, 1, 4, 2, 9, 3. So that is what a basic function looks like when you have a root function, or a radical function is what we call these. You will notice if I pretend that I could take the square root of negative numbers, if I was just pretending, you would notice that a square root function looks like a parabola on its side. So kind of tipped over, which is what you want it to look like. So a square root function is a parabola on its side, but because we can't take the roots of negative numbers, technically we cannot use these points, but the shape would be the same, right? If you turn your screen sideways or your graph sideways, you'll see that that is just the left side of a parabola. 0, 0, 1, 1, 2, 4, 3, 9. All right, let's talk about domain and range. Domain, x values. What's the restriction? Cannot be less than 0, so greater than or equal to 0, but it can be anything else, as long as it's a positive number. Range? Right, y would be the same. Y depends on x. Oops. Y can be a positive number. Okay, we cannot go into the negatives. And last one. This is a semicircle because there is the hint in the name. Did you guys do graphs of circles in grade 11? No, okay, so we're gonna do a couple of notes here. So the equation, okay, I'm gonna shorten it to this. EQN means equation of a, I'm just gonna draw it, circle. You can write the whole words if you like. Equation of a circle. If the radius equals r, so we can put whatever number we want, but we're just going to call the radius r, and the center is at the point 0, 0. So we have a circle on a graph that's centered on the origin. Then the equation looks like this: x squared plus y squared equals r squared. This is the equation of a circle. So if I take the equation of a circle and I solve for y to make it into y equals, I'm going to get y squared equals r squared minus x squared, which means y equals r squared minus x squared, all square rooted. Notice that that looks like this. So what information can we gather from this equation? What do we know about it? The radius is 5. R equals 5 because R squared is 25. Where is the center of the circle? Read the definition. The center of the circle is 0, 0. So here's my circle. My radius is 5, 5, 5. Here's my half circle. Okay, that was really ugly. Let me try again. Circle, circle. Okay, that's as best as that's going to get. All right, so this is a half circle because, again, I have a square root. What happens if I say x is 6? I have 25 minus 36. I end up with a negative number in my square root, which I can't have. So when we graph these kinds of questions, we have to be really mindful of the restrictions here. All right, we have a picture, we have an equation. What is the domain? The restriction here is trickier. Almost. You're on the right track.
The square root of it has to be less than the square root of 25.
X has to be less than or equal to the square root of 25. Or you can write it this way. X has to be between positive and negative 5 in this specific case, based on our picture. Right? Because when we take a square root, we get positive and negative number. So it's got to be between those numbers to work. And then what is our range? What would the range be? What's the restriction? Yes. More than 0, less than 5. Yes. Because it's just this semicircle here. Okay, now if I looked at the generic statement, the generic domain and range for this would be this. X has to be less than or equal to the square root of R. Or you could say negative R between negative and positive R. Either way is okay here. This is the generic if we don't know what R is. Okay, and same with the range. Y has to be between 0 and the radius. In our picture, we know the radius is 5, so we can put in the numbers, but in general, this is what the domain and range would look like. Okay, so going forward, we are going to be manipulating different graphs. These are the basic functions that we need to know. I think there's 7 of them. We are going to be stretching them, moving them, flipping them, putting them together to make pictures, putting them together to fit data. Okay, so in order to be able to do that, we need to know what the basic function looks like and what the restrictions are, so that when we start manipulating them, we're not crossing any boundaries that we shouldn't be doing. All right, on the front page of your booklet, you have your homework assignments written out. Today, your homework is to do questions 1 to 9 in the handout. It is in your workbook. So if you flip to the next page, your homework is already built into there. So you're doing questions 1 to 9. I would also like us to do a couple of things here. If you could please cross out lesson 10 and cross out quiz 4. We are going to have quiz 3 on review day. We are going to have quiz 2 right here, Q2 on the first review. So we're going to have 2 review days. And then we're going to have quiz 1 on day 4 or lesson 4. Yes. Oh, good. I just write them in. So day 4 is quiz 1. Day 7 is quiz 2. Day 11 is quiz 3. Also, inverses, we may end up skipping. So can we just put a question mark next to day 6? We may skip this one. But we're skipping lesson 10 for sure. That can just be crossed out. Okay, so today's homework is in your workbook, question 1 to 9. You have 40 minutes, so you should have plenty of time to do it in class. Off you go. Oh, sorry, 15 minutes. My bad. I'm looking at the clock wrong. Yes.